Electron beam melting metal 3D printing powder bed fusion using an electron beam. Hello, my name is Muhammad Danish Farhan bin Abdul Hamid and my matrix number is AP210250. So in this video, I would like to talk about what is EBM, how it works and the advantages of this process. So let's get started. Basically, EBM is a metal additive manufacturing process. The starting point is a bed of powder metal. That powder metal is fused together layer by layer to build the solid metal part. It's an electron beam doing that fusing. Compared to more common laser powder bed fusion, this is a higher energy process. The electron beam is a higher energy source. Okay, so now I would like to talk about how it works. Basically, electron beam melting typically takes place inside a machine under high temperature. So you start by spreading a layer of metal powder across your build area. You preheat all of that powder and then you use the electron beam to fuse it together, melt it together just in the places where you need to build up your part. You repeat that process over and over and eventually end up with something like a semi-solid block or cake of powder that has all of that preheated powder, regardless of whether or not it was melted with solid parts inside. So you need to break your parts out, depowder them, and then continue on with the rest of the workflow. Now let me move to the advantages of EBM. So let's talk about the advantages of this process. The higher energy source makes it possible to use larger diameter metal powder. That heavier powder metal is easier to work with, safer to work with it. It doesn't pose, for example, the same respiratory risk as fine metal powder. With electron beam melting, it's possible to work with the powder, be around the powder without necessarily needing special safety equipment. Electron beam melting takes place at higher temperature than laser powder bed fusion, which means you have better management over thermal stresses. That means less warping, less distortion, better dimensional accuracy, and it also means that the post-processing steps like hot isostatic pressing or hippling probably are not going to be necessary. It is a more stable build. The control over thermal stresses means that it's not necessary to rely on support structures to anchor the part in place against deformation. The support are there instead just to pin the parts in location for the duration of the build. Support structures can be thinner and easier to remove. Compared to laser powder bed fusion, EBM is typically more productive for a couple of reasons. First, the build rate is just faster, and the second, the ability to stack parts and nest them inside. The build chamber allow you to produce more parts per print. So those are the advantages of EBM. Okay, so that's all from me. Thank you for watching and see you on my next video.